Good morning. Today we're going to start solutions. This is chapter 8. There will be 4 videos for chapter 8. All right, so some first things about solutions. Just remember that those are the homogeneous mixtures, which means they're the same throughout. We generally just call them solutions, but this is the same homogeneous mixture from before. Okay, the minor component is going to be called the solute. Also, this is what's being dissolved. So most of the time we think of solutions like sweet tea or coffee. So the thing that's being dissolved is either the tea or the coffee. If it's sweet tea, it's the sugar. And the solvent is what does the dissolving. Okay, and that would be the water component of it. Generally, it's not always water, but it's just the bigger component, the major one, and it's what does the dissolving. So a dilute solution has a small amount of solute compared to the solvent, but a concentrated solution has a large amount of solute compared to the solvent. So back to that sweet tea analogy. A dilute solution of sweet tea would be not very sweet tea. So somewhere that has sweet tea where you would probably never get it because it's not sweet. You might as well just get unsweet. But the concentrated solution one would be like Chicken Express or sometimes McDonald's. They have very sweet tea. So the main concentration that we're going to focus on is molarity. This is very important. It does come up a ton in Chem 2 if you're taking it. So make sure you understand molarity. Molarity is the moles of solute divided by the volume in liters of solution. Okay, so it's moles over liters. This capital M is the unit for molarity. It does have to be in liters. It cannot be in milliliters. So you'll have to convert it if you're given milliliters. So here we are. First problem. So it says, what is the molarity? Remember, molarity is moles per liter. I have liters, 1.75, but I do not have moles. I have to get moles. But look, it did give me grams. Okay, so I've got to get grams to moles. So 25.5 grams, KBR. Just remember, this is a one-step problem. Grams KBR is 1 mole, KBR. So the molar mass of potassium bromide is 119. So 25.5 divided by 119. I get 0.214 moles. Okay, and then we just do the division, divided by 1.75. Now I get don't forget sig figs, 122 molar KBR. So when you say concentrations that are in a molarity, you call them molar, kind of like the tooth. Okay, let's do another one. This one's a little bit bigger. We've got 45.4 grams of sodium nitrate, and we've got 2.5 liters. So 2.5 liters. I do not have moles, so we have to solve that again. So 45.4 grams. I have 22.99 plus 14.01 plus 48, 85. I get 0.535. I get 0.214 molar. sodium nitrate. Don't forget, you've got to put the compound because in a little bit we're going to start stoichiometry with these. Okay, I do want to go ahead and work this one just because it's a little different. Okay, so this one, first off, it has milliliters. It gives us molarity, and it's asking for grams, so we're going to go backwards. So we have to find moles to be able to get grams. Okay, so if molarity is equal to moles per liter, then moles is equal to molarity times liters. Okay, my molarity is 1.5. And for milliliters to liters, you have to divide by 1,000. So this is 0.25 liters. And so I get moles is 0.375 kBr. Our mass, I think, was 119. Scroll up in my calculator. Yep, 119. I get 44.6 grams. So it's just a matter of doing some algebra with that equation and then solving for what it's asking for. All right, so we will use molarity as a conversion factor, and that's because it has 2 units. Remember, anything with 2 units can be a conversion factor, and you just split it. I do want to be very clear for these, though. So this says 0.5 molar NaCl. The 0.5 goes with the moles. The number will always go with the moles. The liters will always be 1 for these situations because it's per liter. So here we're looking for liters. Remember, so we could use this. So molarity is moles per liter. I'm looking for liters. So liters is equal to moles divided by molarity. Okay. So I have 0.255 moles divided by 0.125 moles per liter. Okay, the reason I know this is the equation, so my moles cancel. Liters is a denominator in the denominator, and just remember, if it's in this denominator twice, like if it's in the denominator of the denominator, it goes back to the top. Because remember, when you divide by a fraction, you flip it and then multiply, so that liters comes back up to the top. And I get 2.04. NaOH. Okay, so that is one way to do it. We can also start with the one with a single unit, so 0.255. We can do a conversion, so 0.125 moles is 1 liter. Okay, and it's the same process. So I don't care which way you go. I do need you to know they're the same answer. It's the same process. We did the same math. Okay. I do need you to know this method with the conversion factor is going to be used when we do solution stoichiometry in a few minutes. All right, let's do another one. This one wants grams. So remember, moles was molarity times liters. Okay, so I have 1.55 liters times 0.758 molar. And I get 1.1749, and that's moles of sucrose, C12, H22O11. Okay, but it wants grams, so 1 mole of sucrose, I'm just going to write sucrose, is equal to grams of sucrose. So All right, sorry about my dog, y'all. The mass of this is 342.34. Remember, we don't round to the end. I need 3 sig figs, so I get 402 grams of sucrose. Okay, there's going to be one more. We're not going to work that one. When we prepare a solution in lab, and I know y'all aren't going to be doing this, but it is important to know in case you take Chem 2 and you have a in-class experience with lab. Also, you could see this in a higher level chemistry class. Okay, so we always use these volumetric flasks. That's what this is called, volumetric flask. It does have one line, which makes it very precise. This specific volumetric flask is a liter, but they go all the way down to 5 milliliters, and they go all the way up to about 5 liters. But those just get really heavy, so normally we don't use them. I make solutions all the time at the high school. I don't have to do that at the college because we have lab people. But when you make a solution, normally you have a solid. So you weigh out however much of your solid you need. Remember, we do molarity in moles, but we have to know how many grams that is. Okay, so you weigh out however many moles you need based on the grams, and then you fill it up to the water line. It is very important that you put only some water in it first, and then you kind of swirl it around. Sometimes you have to heat them depending on how soluble it is. But other times you can just swirl it, it'll dissolve, and then you fill the rest up to the line. It is also very important that this must be distilled water, because it needs to be just pure water. Distilled or DI, which is deionized. That just means it's pure water. We took all the ions out that are in normal tap water. All right, we're also going to talk about dilutions. And so when we do a dilution, we may have a highly concentrated liquid, and I need to have a less concentrated liquid. Okay, so I like this equation better personally at the bottom. M1V1 is equal to M2V2. So those are molarities. And when I multiply molarity, remember that equals moles. Molarity and volume is moles. So it's just saying the moles of the solute of 1 are equal to the moles of the solute of 2, which means we did not destroy matter, which is what is important. Okay, so the volume is changing, the concentration is changing, but the moles are staying the same. Okay, so I do this a lot in the high school with acids and bases, so I do by the highest concentration I can, and then we dilute them down because it's just way cheaper. So here we've got 15 or 1.15 liters, so 150 mils of that 10 molar solution, and they wanted a 0.5 molar solution. Okay, so we use M1V1 is equal to M2V2, so I do it's 10 molar times 0.15 liters is equal to, they wanted 0.5 molar times V2. We're trying to see how much volume I need. So all we do is multiply our 10 times 0.15, and we divide it by 0.5, and I get 3 liters. So that is our final volume. Okay, so let's do another one. I've got, remember our equation is M1V1 equals M2V2. These should be the easiest ones. Sometimes students get confused on what goes where. I don't care if you put them at M1 or M2, just as long as the ones that go together go together. Normally this of means those are the ones that go together. So I have 15 molar into 0.2 liters. It's equal to 3 molar. And V2 is what I'm looking for. You don't always look for V2, but it's pretty common. Also, something to note, I did not write all the correct sig figs. You need to be careful with that. So this comes out to 1 liter. However, all of those have 3 sig figs, so it's 1.00 liters of NaOH. Also, something important with dilutions is it is the same compound at the beginning and the end. Okay, now this one asks volume in milliliters. If both of them are in milliliters, you can leave them. So I have 5 molar times 100 ml is equal to 0.75 molar times V2. Now I get 667 ml of calcium chloride. Okay, one more. I do like this one because I would say this one is M1. Sorry, 6 is M1, but we're looking for V1. It doesn't matter what you're looking for. Okay, so just make sure the two that you have multiplied are the ones that you actually do the multiplication for, and you divide by the one by itself. So V1 is 0.105 liters of sodium nitrate. That's for this one. Okay, please let me know if y'all have any questions on either molarity or dilutions. Okay, so now we're going to use molarity as that conversion factor to do solution stoichiometry. This will be on the test. Make sure you know how to do it. So these have a whole lot of givens. Remember before, if we had more than one given, you assumed it was limiting reactant. But this is not a limiting reactant problem. Okay, the way I know that is because I've only got one thing that I can truly start with. This. You can only truly start with the given with one unit. Because remember, molarity is moles per liter. That's not 1 unit. That's 2 units. So I've got 0.15 liters of lead nitrate. Lead 2 nitrate, actually. So remember, liters of lead 2 nitrate has to go at the bottom. And moles is on top because this is molarity. Okay, they gave us the molarity is 0.175. Remember, the number goes with the moles. The liter number is 1. Okay, now it wants us to get to KCl. So this is our mole ratio from before when we were doing stoichiometry. So PbNO3 goes on bottom. Remember, it's wanted over given. KCl goes on top. In this problem, I have 2 KCl's. For every 1 lead 2 nitrate. And it wants volume. So moles has to go on bottom. Liters of KCl on top. And it's 0.15. Okay, so now we can do the math. Our units, make sure they cancel to what we want. I'm left with liters. It wants liters of KCl, so we're good. I get 0.35, but I need 366. So it should be 0.350 liters KCl. Okay, it's going to go through the whole thing. There it is, 0.35. Okay, we are going to do both of these problems, so just bear with me. This one asks for volume in milliliters, but it starts in milliliters. So remember, this is kind of like kilograms. If they're both the same, you can leave them. Okay, so you still got to start with volume. 35.7 ml of sodium carbonate is ml. Really, that should just be L. It was 0.108 is 1. Now we do the mole ratio. That mole ratio is generally that second step. Okay, so I've got 1 sodium carbonate and 2 nitric acids. And I've got 0.15 moles of our nitric acid to every 1 liter of nitric acid, because remember, it told me 0.15 molar. Okay, so remember, these 2 liters cancel. This cancels here. Moles, 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 moles. So I'm left with milliliters of nitric acid. Again, this only works if they're both milliliters or they're both that kilograms from just normal stoichiometry. So I get 51.4 ml HNO3 nitric acid. Okay, the next question, uses the same equation. It uses the same given to start with, but it wants to know how much CO2 forms in grams. So I'm no longer going to use that. I don't need it. I do, however, need to start with this 35.7, but now because I don't have milliliters on both sides, I have milliliters and grams, I've got to convert that to liters. So I've got 0.0357 liters sodium carbonate. This step is the same, 0.108. Mole ratio, the bottom part is the same. So my given is still the same, but now the top one is different. This is 1 mole of carbon dioxide. I've got 1 mole CO2 is 44.01 grams CO2. I get 0.170. Okay, again, still make sure your units come out to the correct units. Make sure your sig figs are good. If y'all need practice with any of these topics, molarity, dilutions, or solution stoichiometry, along with the parts of a solution, please let me know. Y'all have a good day.